Okay, this is Dr. Bishop once again, and I'm going to make a video here of correlational research methods, correlational research. To begin, I want to just mention that the reason I'm focusing on this is that correlation coefficients in correlational methodology is used to measure to help define the concepts of reliability, which is a really important concept, and validity. However, this topic is more general, and it's just a good thing to understand. So anyway, the way to start here is a study of a relationship between two or more variables. Now, to begin with, a variable is anything that can have more than one value, which is almost everything. Height, weight, temperature, sexual orientation, gender, male, female, almost anything. So typically with correlation, you have two variables, and you want to know whether, as one varies in a particular direction, the other one also varies in the same direction or the opposite direction. For example, height and weight. As you get taller, you're more likely to be heavier. That's generally true, but not completely. So basically, variables, when you do correlational research, it's important to note that variables are measured as they already exist and that nothing is manipulated. So you just select a particular two variables and then you measure them, and for each subject you take a measure on each variable. So an example of correlational research would be that you administer a survey to a large group of students, say intro psych students, and your survey includes questions about your current alcohol use and your current GPA. So you have the variables of alcohol use and GPA, and then you, through mathematical manipulations and you basically a set of numerical procedures and formulas, and you calculate something called a correlation coefficient. So the key question here is, are alcohol use and GPA related? Do people who drink more alcohol also have lower grades? That actually, if that were true, that would be a negative correlation. As one variable increases alcohol use, the other decreases grade point average. So the correlation coefficient is, the symbol for this is R, and the number represents the strength and direction of the relationship between the two variables. So the strength is the absolute number between 0 and 1, and the direction is either a minus or a plus. The plus being as one variable gets a positive correlation, as one variable gets greater, the other also. A negative correlation as one variable increases, the other decreases. So here's some examples here in the bottom of correlation coefficients after you do the numerical procedures and calculate a correlation coefficient. So as I just mentioned, you can have a positive correlation, and you can read this for yourself. Variable X associated with higher scores than variable Y. For example, stress positively correlated with depression. Higher stress, higher depression. ACT is correlated, actually it's correlated 0.5 with the college GPA. So if your ACT score is higher, the probability is that your GPA may be higher, although this is not a perfect relationship. Educational achievement is positively correlated with income. Negative, by the way, the highest positive correlation I heard of in graduate school was number of cricket chirps per minute and temperature. The correlation was positive 0.97. So if you knew either of those two variables, you could predict the other one almost perfectly. A negative correlation is one gets greater, the other gets lower. So social support negatively correlated with depression. More social support you get, the lower the depression. Amount of aerobic exercise per week and body weight. The more exercise you get, the more likely you are to be thinner, or the thinner you are, maybe, the more exercise you get per week. Marital conflict is negatively correlated with marital satisfaction. So if you're fighting all the time, if you have a measure of satisfaction, it's going to be lower. So the higher the absolute value, as I mentioned before, the stronger the relationship. So 0.92 is greater than 0.65, but, and here's the catch, a minus 0.83 is a greater correlation than a 0.24. So when you're talking about the degree of relationship, you ignore the sign and just look at the absolute value. A 0 means there is no relationship between the variables. As one varies, the other does not vary with the first. Scatter plots are they're pictorial representations of the data that you get when you calculate a correlation coefficient and you collect data on two variables for a single subject. A key point is that each point on the graph represents a subject in the data set. So here's some examples, and actually this is just theoretical, but the number of hours to study for the first exam is on the y-axis, right here, 5, 10, number of hours. And the score on the first exam is percentage correct. Now, in this first one, you see a positive correlation, so I believe, no, actually, the correlation here is 0, right here. And so the higher the number of hours you study, it didn't correlate with performance, which is typically not the case. Here you get a correlation of 0.30, and you can see that in general, the trend is the more you study, the higher you score. This is more typical. If the correlation was even higher, what they call the scatter plot, which is the distribution of points, is narrower if you drew a circle around it, and you get, if you calculate the correlation coefficient, it's 0.80. That's a good sized correlation. If you get that, for example, if you were doing diagnostic reliability and you had two psychiatrists and they rated the same patient, and you had several patients, and you found that both psychiatrists agreed most of the time, and you then graphed it as a scatter plot, you would get something that would look like this. It's very rare, but occasionally you'll get a perfect correlation. Again, the highest that I heard was the number of cricket chirps per minute and temperature. So if you had the crickets were going like crazy, if you actually have the data, you could actually predict almost perfectly the temperature, and vice versa again. So when you have a, quote, nonlinear relationship, it means you have no relationship and the correlation coefficient is 0. The y-axis is the hours of study, and this is the exam total, and there's no correlation here. So maybe the test didn't test the sort of things that people were studying, so there was no correlation. Again, here is what it looks like: a 0.3 correlation, a 0.8 correlation, and a perfect correlation where all the points fall exactly on a straight line. Number of beers per night before the first exam on the y-axis, and the score on the x-axis. So again, you can see, depending on the figure you get for the correlation coefficient, in this case, you're getting a negative. So the more beer you drink, the lower the score on the test. So you can see a little bit of this in this scatter plot here, and you get to a correlation of minus 0.80. You can see that the number of beers that that you consumed the first night. So if you did 20, then there's your, let's see here, the y-axis score on the first exam. I'm not sure this is absolutely correct here. Okay, coming back here, I had myself a little bit confused, but basically the x-axis is if you only got 50% of the items correct on the test. So the more you drank, if you're up here in the 20, and if it's a high correlation, then the lower your score. So you drink 20 beers, you only get 50%. If you drink practically no beer, you get closer to 100%. This sort of inverse relationship is what shows up in a negative scatter plot. And if it were a perfect correlation, again, a minus 0.1, the data set would look like this. And a little easier thing to see here, same thing. Minus 0.7, minus 0.4, and if there's no relationship at all, it looks like this. Okay, here's a review question. Which of the following variables would you expect to be negatively correlated? Number of cigarettes smoked, number of alcoholic beverages consumed. Actually, I'll just tell you, there's a positive correlation if you go to an AA meeting. People generally that consume a lot of alcohol also smoke a lot. So that's a positive correlation. That wouldn't be right. Salary and job satisfaction, that also would be a positive correlation. Number of servings of vegetables and body weight, that would be a negative correlation. The more vegetables you eat, probably you keep a good weight. So the answer there is C. A number of unprotected sexual encounters and STD infections, there's a positive correlation there. More than 6 or 8 partners, you begin to get a positive correlation between that and STD infections. So which of the following correlation coefficients represents the strongest relationship between two variables? If you look at that, you should be able to tell that it's 0.93 minus 0.93. It's the 0.93 that determines the degree of relationship without reference to the direction of the relationship. Car insurance company wants to know your gender, age, marital status because these things predict the likelihood you'll be involved in an auto accident. They have statisticians who analyze these variables, relate the risk for being involved in an accident. Which predictor variable are they most interested in? One with a correlation coefficient of, again, if you're looking at prediction, you want absolute number, not direction of correlation. So the answer here is 0.73, minus 0.73. There are some limitations to correlational research, and this is particularly important because most research you hear about on TV and in many situations is correlational. And so you cannot draw conclusions about cause-effect, just that there's a relationship. Alcohol use and GPA, administer questions, current alcohol use, GPA. Results show there's a negative correlation. Students who currently consume greater amount have lower GPAs. What does this mean? Does it mean that drinking greater amounts causes students to get lower grades? You've got at least three possible interpretations. And generally, with correlation, you have multiple interpretations. And there's no way, there's confounding, there's no way to actually untangle it and determine which is the correct interpretation. So you could have heavy drinking actually does cause low grades. That's one possibility. You could also say you have low grades and then it turns out that you get stressed out and you start drinking because you're depressed or something like that. So it may be that the GPA, low GPA leads to alcohol use. Or you could have some third variable, stress, that relates to a lower GPA and also higher alcohol use. So it may be some unrelated variable. So you have this directionality problem with correlation. You don't know whether drinking more alcohol causes students to get lower grades or whether getting lower grades causes students to drink more alcohol, or so that's the directionality problem. You know they're correlated, but you don't know which direction the relationship goes, or even if there might be some other variable. Now, one of the things you can do if you have two variables and they're related, you can actually conduct longitudinal research. So you can measure students multiple times throughout a semester, include questions each time, and you can check to see which thing comes first. Does the drinking come first and then the lower grades, or the lower grades and then the drinking? So that helps you untangle them to a certain degree, but still there may be alternative explanations. Correlational research is frustrating because you don't know exactly how to interpret it, but it does give you some clues, and it does help you predict. Again, the third variable problem is what I just mentioned, and sometimes you can address this through statistical manipulations. This is a little beyond where I want to go in this course, but there are ways that you can try to figure out what's going on and some other variable involved. Let's see here. Imagine listening to a talk radio, or guest speaker says behavioral science research shows there's a positive correlation between age at which teens first become sexually active and self-esteem. This means that waiting until one is older to have sex for the first time causes higher self-esteem among teens. Is this interpretation warranted? The answer is no, because again, you can't prove that. It could be others. So you could be that waiting until it's older, begin having sex, causes teens to have higher self-esteem. Could be that people with higher self-esteem causes people to wait to begin having sex. Or there could be some third variable, for example, a conservative parent that causes teens to both wait and to have higher self-esteem. And again, how could we know whether having sex at an earlier age causes low self-esteem? You could do a longitudinal study, measure self-esteem and early sex, and see if one comes before the other. And you could measure some other third variables and statistically control for them. But again, that's probably beyond where I want to go here. To know for sure whether having sex at an early age causes low self-esteem, you must conduct a true experiment, which is, in this case, practically impossible to do because you have to manipulate independent variables. You have to control when participants have sex for the first time, so you have a couple of groups and you assign subjects randomly and you say, okay, experimental group, go out and have sex at 14, and the others you wait until you're 18. And you get them assigned to groups, and then if you could actually control that, you could have a real experiment. But obviously, and then you'd measure to see if it had an effect on self-esteem. But obviously, you can't do that kind of experiment. And in many cases, the same thing occurs when you're doing research. For example, you want to know if early abuse, physical or sexual abuse, leads to multiple personality disorder. You can't take a sample of people and say, okay, you go abuse, have your parents abuse you, and the other group say, you treat them really good, and then measure it later. So you just have to measure what's available, which again, you can't control for other variables, extraneous variables. It could also be involved in establishing the disorder. Correlational research is often used in epidemiological research, where again you study the incidence, prevalence. You see who is the example I gave in an earlier lecture was whether someone had AIDS or HIV infection, and then determine what's correlated with that, and then you label those things risk factors. You need to get correlation coefficients between having the condition and then some risk factors. Some of the risk factors, again, for HIV infection were being gay, being male, having a lot of sex partners, having specific types of sexual activity, and so forth. Correlational research is also used in behavioral genetics research. You study the heritability of different mental disorders. For example, you can correlate whether someone shares genes, the degree to which they share genes, and if that's correlated with the likelihood of having a particular mental disorder, for example, schizophrenia or bipolar disorder. It turns out, actually, that there's a substantial correlation between the number of shared genes and having those two disorders. So this is an example of behavioral genetics research, and it helps determine what may be going on and causing a particular mental disorder. Okay, we're going to stop there.